Congratulations, you finally unlocked coal power, the first milestone available in Tier 3 of the hub. Yes, that's right, the time of gathering biomass materials for your biomass burners has finally come to an end. Coal power introduces water as a resource, and this is delivered via pipes, a simple but sometimes confusing topic that I will help you understand. If you're just here for the technical information and don't want the reasons why, then your answer is 8 coal generators needing 120 coal per minute and 360 water per minute from 3 water extractors will make 600 megawatts of power. This is the most common build used in Satisfactory. So I just threw a bunch of numbers at you and you're probably wondering what they mean. Well, let's look at the coal generator. It is the first machine you come across with 2 inputs of different types. On the left is a pipe and the right is a conveyor. A coal generator requires 15 coal per minute and 45 water per minute, and it generates 75 megawatts of power. So why did I mention 8 coal generators? Where did I pull that magic number from? Well, let's look at your current stage in the game progression. You will have unlocked Mark II belts, and these transport resources at a speed of 120 per minute. With a miner on a normal or pure coal node, you will be able to feed that belt with 120 coal per minute. Be aware that the miner on the normal node will need to be overclocked to 200%, otherwise it will only provide 60 coal per minute. You will need to have unlocked overclock production in the MAM under the Power Slugs branch to be able to overclock a Mark I miner on a normal node. If you're on a pure node, then this is not necessary. Now that we know the maximum amount of coal we can supply on a single belt is 120, and each coal generator requires 15 coal. Dividing 120 by 15 gives us 8, meaning we can optimally fuel 8 coal generators off a single belt. Looking at this build screenshot, you can see a belt manifold is used to feed this coal to all 8 of the generators. Now let's look at water. Each coal generator consumes 45 water per minute. So if we multiply 45 by 8, we get 360, meaning we need to supply 360 water per minute to these 8 coal generators. The water extractor machine was also just unlocked, and each water extractor can supply 120 water per minute. If we divide 360 by 120, we get 3. That means we need 3 water extractors to optimally fuel 8 coal generators. Wow! All these perfect numbers, it's almost like the game developers made it nice and easy. That water will be transported by a Mark I pipe. And looking at what a Mark I pipe can transport, it's limited to 300 per minute. Wait up, so how are we going to able to feed 8 coal generators needing 360 water per minute when that exceeds the pipe maximum throughput rate of 300 per minute? Well, there's nothing saying that we need to supply that water through just one pipe. It comes down to how you connect those water extractors to the coal generators. Looking at this build screenshot, you can see a pipe manifold is used to feed this water to all 8 of the generators, but as previously stated, that's technically not possible. If we use 3 pipes from the 3 water extractors, we can feed the manifold separately from each end and also from the middle. This effectively distributes that 360 water to all 8 coal generators without exceeding the Mark I pipe limitation of 300 per minute. You can see the 2 generators at each end will take 45 water each, and the remaining 30 water feeds to the generators numbers 3 and 6. The third water extractor feeds in from the middle, so generators number 4 and 5 take 45 each, and then the remaining 30 is split in half for the generators numbered 3 and 6. That means generators 3 and 6 both receive 30 and 15 water, making the 45 required. The thing that is different between belts and pipes is direction. A conveyor belt only moves materials in one direction, whereas fluids in a pipe have no direction limitation. Fluids will flow to the lowest point in the pipe network regardless of direction. Technically, in the example above, the coal generators 1, 2 and 3 are the furthest away from the water extractor, so on initial startup, the water flowing into the manifold from the other water extractors will arrive sooner and will be distributed across the entire manifold, but will be balanced back not long after. Now with everything hooked up, you're going to need to provide power to the water extractors and the coal miner to initially start the coal generators. The 3 water extractors will require 60 megawatts, and the Mark 1 miner on a normal node overclocked to 200% will require 12.5 megawatts. With a total of 72.5 megawatts required, 3 biomass burners will suffice. You will need enough fuel in the biomass burners to allow time for the coal to travel from the miner to the coal generators, and the same applies for the water extractors. One last thing, the coal generators will not start producing power until their power connector at the rear of the machine is connected to a power pole or power connector. Once the coal generators are running and stable, you can disconnect the power from the biomass burners and connect them to the coal generator power grid. Keep in mind though, if you were to exceed your power capacity on the power grid, the grid will trip and there might be a hassle getting the coal generators up and running. The grid will only trip once you try to pull more power than the grid can supply. A logical option here is to dedicate a separate infrastructure power grid for the machines that provide the resources to the generators. With this setup I've just built, one coal generator generates 75 megawatts of power, and we required 72.5 megawatts to run the miner and the water extractors. So in this case, we just need to disconnect one of the coal generators from the main power grid and create a dedicated infrastructure power grid for these machines. Now, in the event of the main power grid being tripped, the machines providing the coal and the water to the coal generators will continue to run and are not affected by this tripped power grid. You will of course have to fix the issue that caused the main grid to trip, but you can rest assured knowing that the coal generators themselves are receiving their required resources. Of course, every time you build more coal generators, you will need to dedicate additional coal generators to the infrastructure power grid for the new miners and water extractors required to fuel those new coal generators. And that's it. By following these steps, you will now have stable, self-sustaining power for your power grid. But it doesn't stop there. I have some additional information to share with you that will make your life easier. When using a conveyor belt manifold, the machines at the end of the manifold will take a long time to receive coal, as each machine along the manifold receives half of the coal and so on. This will lead to unreliable power until the whole manifold is saturated. So a way to avoid this is to preload each coal generator with a stack of coal. Using a load balanced input instead of a manifold will prevent this from occurring. For more information on this, check out my manifold versus load balancing article on the Satisfactory Guru website. Water extractors have a head lift limitation of 10 meters vertically, which is measured from the center point of its pipe output. You can use 5 2-meter foundations stacked vertically to provide a visual guide of what 10 meters is. When you need to send water higher than 10 meters, you will need to add a powered pipeline pump before the 10-meter limitation. A Mark 1 pipeline pump adds 20 meters of head lift, and the Mark II adds 50 meters of head lift. Check the Satisfactory Guru website for more articles about fluid dynamics. If you haven't already realized, Satisfactory is a math game in disguise with logistics puzzles thrown in. Armed with this knowledge, go forth and build lots and lots of coal power setups in preparation for the next stages of the game. The Upgrading Coal Power Guide is also worth checking out. It goes into detailed information on how to expand your existing coal power and also looks at alternate builds of coal power. I hope you found this helpful. If so, drop a comment and let me know how. Don't forget to visit the Satisfactory Guru website or drop by my stream on Twitch and say hi. Have a great day and I'll see you in another video.